All right. So another example here of a rational function. Let's look at f of x. And there's the more sort of different degree that we have, the larger the degree of everything, the more complicated, right, the problem is. So let's look at f of x. Let's look at one that's got a little bit of a complication here since we've done some of these already. Let's look at x squared minus 2x minus 8 all over x plus 3. So this is a rational function. So we're concerned about asymptotes as well as intercepts, right? With a polynomial function, we are very concerned about x-intercepts and also the end behavior, right? With a rational function, the end behavior is really the horizontal asymptotes. And the intercepts we also are still interested in, but we also have to be worried about vertical asymptotes. So we can really attack each of those things in any order you want. So you may want to notice right here in the beginning that by comparing the degrees, since the degree on the top is 1 larger than the degree on the bottom, that's going to give us an oblique asymptote. We find oblique asymptotes by doing division. We could do long division, or in this case, we could do synthetic division. When we do our synthetic division here, right, we add those together and multiply those, and add those together. This tells us that we get x minus 5 is my, right, this piece tells me that x minus 5 is my quotient. 7 is my remainder. So we know that my oblique asymptote is y equals x minus 5. So I don't have a horizontal asymptote, I have an oblique or a slant asymptote. We also are interested in the vertical asymptotes. The vertical asymptote is where the bottom equals 0, as long as the top does not equal 0 as well. So I also, at the same time, I want to check for x-intercepts. The x-intercepts happen where the numerator equals 0. The numerator here in its factored form is x minus 4 and x plus 2. These values don't match up with that value. So I don't have to, I can be sure that this is going to give me a vertical asymptote at x equals minus 3. So that's my vertical asymptote. These values are my x-intercepts. Those are at x equals 4 and x equals negative 2. So those are my critical pieces that I want to be able to find for this function. I have my oblique asymptote, I have my vertical asymptote, and I have my x-intercepts. And a lot of questions will just be find those things. But we do want to try and be able to put them all together to come up with a graph as well. So let's see if we can do that, or some version of that. I have a vertical asymptote at minus 3. So that's right there. And I have x-intercepts at negative 2 and at 4. So the question then is, how do I put in this oblique asymptote? That's the line y equals x minus 5. So we know what that line looks like. It has a slope of 1. And it goes through minus 5. Right? Notice when x equals 5, that line is 0. Y equals 0. So it goes through that point as well. And then I also have my horizontal asymptote. Well, no, so that's my oblique asymptote, right? I don't have a horizontal asymptote. So what happens here sometimes, and you can see it happening with this, with what I've done, is that my graph that I've drawn isn't like very well situated with what's happening with the function. So what I'm going to do is I'm going to redraw this now that I see a little more about what's happening. I'm going to redraw it in a way that hopefully gives me a little bit better space to operate. And that's pretty common that we need to do that. So I'm going to draw it a little more up here. See, I was kind of missing this bottom section down at the bottom with my first graph. So I sort of expanded this a little bit. And one of the critical things is that the graph you draw, we know what has to happen near the vertical asymptote, right? This function has to be approaching the oblique asymptote, and then it either has to be going up or down as it comes to that vertical asymptote. So I have really two options here on this left portion. Can you see that it cannot be this upper option? Because if it looked like that, it would have to have an x-intercept right there, and it doesn't, right? So usually in these situations, you can figure out which of the possibilities is possible, which of the options is possible, and it has to be that one. If you run into trouble and you cannot figure it out, you can plot a point, right? So if I put in a point here like x equals -4, I would find that y value to be somewhere down here, right? I don't want to do that often because it takes some time and energy, but that's certainly something I could do. Over here, I can see the function has these two x-intercepts. So I might want to fill in with maybe the y-intercept just to give me an extra point. The y-intercept is f of 0. F of 0 is going to be -8/3. So that's just over -2. That's somewhere in there. So that tells me, again, knowing what vertical and oblique asymptotes have to look like, that tells me my function has to look something like that in that region. So that's a good graph or a good sketch of this function, right? It shows the oblique asymptote, it shows the correct x-intercepts, it shows the correct vertical asymptote, and it shows the right behavior of the function near each of those features. So that's what I'm looking for if I ask you to come up with a graph.